All right, so we're going to talk about Chapter 10, Lesson 7 today. It's all about theoretical and experimental probability. We'll talk about the differences between them and how we can utilize both to help us solve problems. So, first of all, theoretical probability. The key word here is theoretical, which means it's not really doing anything. It's what should happen, not what does happen. So theoretical probability is what should happen after doing the math. And what we're going to be talking about here is specifically, this is just like in Lesson 6, this is going to be doing the probability of something happening. Experimental probability, that's the exact opposite. This is what actually happens after trying the activity. So they are exactly the opposite. Theoretical is what should happen without doing anything, and the experimental probability is what actually happens without doing the math. So, example 1, a coin is tossed 40 times and lands on heads 18 times. Find the experimental probability and compare it to the theoretical. So, first of all, the experimental probability. It happened 18 times out of 40. And if we go ahead and simplify this, the only common factor is 2. So 18 divided by 2 is 9. 40 divided by 2 is 20. Now the theoretical probability is what should happen. So if a coin is tossed 40 times, the probability of landing on a heads is 1 out of 2. So if it's tossed 40 times, it should come up 20 times. Or if we were to simplify that down, it would be 10 out of 20. So it should happen half the time. Or 20 out of 40 times. If we simplify that down to get to the same one here, it would be 10 out of 20. So they are slightly different. So what we say when it says to compare it to the theoretical probability, we would say the experimental probability so the experimental probability occurred less often than expected, or again, this is the theoretical. So what happened is it happened less often than what should have happened. Simply because when we actually did it, it happened 18 when it should have happened 20 if it happened all according to how the math predicted it should. And that's the difference between experimental and theoretical. Experimental is what actually happens, theoretical is what should happen. So let's look at the backside here now, making a prediction. When we make a prediction, we can use the probabilities to predict what should happen. So, for example, on the last one, what should have happened was it should have landed on heads half the time. And if it went 40 times, that means it should have landed 20 times. But it didn't. But we can use that to make a prediction to see exactly how many students or how many things should happen or we should expect to see. So, example 2, it says Miss Newman surveyed her class to see which sports they preferred watching. 44% preferred football, 28% preferred basketball, 20% preferred soccer, and 8% preferred tennis. Out of 560 students in the entire school, how many would you expect to prefer watching basketball? So, she surveyed her class. 28% said they would like to watch basketball. We can use that to predict how many students we should expect to see prefer watching basketball from the entire school. We don't have to survey the entire school. We can use this percent here to help us to predict. So just like with lesson 5, we're going to do a percent proportion. And we're going to do the part over the whole is equal to the 28 over 100. So if we go ahead and do cross products here, the 560 times 28 and the 100 times x, we get 100x equals 15680. We want to solve for x, so divide by 100 on both sides. We get x equals 156.8. So we would expect to see about 157 students who would prefer watching basketball. Now, that number might not necessarily be true, but we're using a theoretical probability in order to predict how much should happen. If we wanted to find out the actual number, we'd have to go through and survey every single student to figure that out. All right, this is the end of lesson 7. If you have any questions, please let me know.